In this video, we're going to look at solving cubic equations. We're asked to solve this cubic equation. First, when we look at this cubic equation, we might notice that 2 is a common factor of each of the terms on the left-hand side. So we could start off by simplifying this equation if we divide each term by 2. This creates a different equation, but it's an equation with the same roots as the given equation. So dividing each term by 2, we'll get x cubed minus 2x squared minus 11x plus 12 equals 0. So this is the equation that I'm going to solve. We're going to use the factor theorem. Using the factor theorem, if we sub in different values for x, we're trying to see what value of x would give an output of 0. We might sub in the value 1, for instance. When we sub in 1, we see that we do get negative 13 and positive 13, which adds up to 0. Therefore, we can conclude by the factor theorem that x equals 1 is a solution. We're expecting 3 solutions to a cubic equation. We have one of them here already, so we're partly through the problem. We also know by the factor theorem that a related factor to this solution is the factor x minus 1. If I divide this factor into the cubic equation, it should go in evenly and give us the quadratic factor we're missing. So x minus 1, I'm putting this one side of the array. We know where to place the x cubed term, and we know where to place the plus 12. X goes into x cubed x squared times, and negative 1 goes into negative 12 times. When we multiply x by negative 12, we get negative 12x. We want the x diagonal to add up to negative 11x. So we need to add 1x to the negative 12x to make this happen. Now if we divide negative 1 into 1x goes negative 1x times. We have our quadratic here, but we just check that we're right by multiplying out the x squared column and seeing that it adds up to negative 2x squared, and we see that it does. So now we have a quadratic as well as a linear factor. So if we factorize this quadratic, we will end up with the missing 2 linear factors. We'll have all 3 then. This is a fairly trivial quadratic, x squared minus x minus 12. So we could do this probably in our heads just by inspection. So we'll do our brackets. Factors of x squared are x and x. And the factors of negative 12 that add up to negative 1 will be negative 4 and positive 3. So now we have all 3 factors. So that we have all 3 factors, we have all the solutions. Let's just show the factors together. So our expression in terms of factors is x minus 1, x minus 4, and x plus 3. And this is our cubic expression, which equals 0. If that equals 0, it's because of the following reasons, because the x values that would make that equal 0 would be x equals 1, x equals 4, and x equals negative 3. So we have found the solutions to our cubic equation, or at least to a cubic equation with the same roots as the given one. We could have used a calculator to help us do this. So using the calculator and the table function on the Casio, if we enter in the cubic expression, x cubed minus 2x squared minus 11x plus 12, we start maybe at negative 6, go up to 6, and go in steps of 1 because it's just x squared. And we're looking for inputs that give an output of 0. We see negative 3 is 1, 1 is 1, and 4. So we see we get the same 3 answers we have here. So the calculator could have given it these answers straight away, although the calculator may not always work if the solutions are more awkward.